So, good morning, everybody. Don't forget, I guess this is a question on differentiation. Don't worry, I know seeing questions like this might scare you, but trust me, you don't have to be scared. Just keep calm, relax yourself, and pay attention. Now, what is important is that when you see a question like this, as you can see, you are having y is exponent sine open bracket x squared plus 1. And you are asked to find the dy dx if y is equal to all of this. Now, how do I go about finding the dy dx? All that is needed for you to do is you understand the principle behind, because from the look of what I have here, I think I have a function in a function. This is a function. I have a function sine open bracket x squared plus 1 contained in this exponent. You understand? So I have an exponential function here that has this particular one in it. Therefore, we have to apply our concept of function of a function. Trust me, you don't have to run, you don't have to be scared. If after this class, you understand, or just wait, let's place a bet. By the time you watch this video and you still don't find it interesting, don't watch my video again. But by the time you watch the video and you find it interesting, then do all things to please you. So the first thing I would like to do is listen. Now, what I will do is, most times you just follow this procedure. There is a procedure to solving questions like this, and just follow my procedure. So the first thing I will do, I would assume let u solution. Let u be equal to the inner function, which happens to be sine open bracket s squared plus 1. Automatically, these problems are they are compound problems. And the reason is because I think I have a composite function here. And I'm not just having two functions. I'm having a function in a function in a function. Yes, I have s squared plus 1 is a function. Sine is a function. Exponent is another function. So I'm having a function in a function in a function. So what do I need to do? At this point in time, I'm having another problem here. There's a problem here. And this problem requires me to still take that idea of a function chain rule. So what I'll still do again, to solve something like this, you are still going to let n, you understand? Let me represent s squared plus 1 with something. You understand? So I'm assuming I'm using n. So the n, the x, differentiate n with respect to x. So by differentiating n with respect to x, we end up getting a 2x. Yes. 1 times 2 or 2 times 1. Then deduct 1 from the power here. The differential of constant is 0. So therefore we end up getting this particular thing here. So after getting this, the next thing is you end up having that u is equal to, go back to the initial function, which was u is this. So that I end up having sine. Instead of writing everything here, I would replace it with letter n now. Since I said n is equal to all of this. So that means this particular thing here can take u is equal to sine n. I can write it that way. Therefore, if I decide to find my du, dm, you differentiate u with respect to n. Differentiating u with respect to n. Don't forget, I gave you the differential of trigonometries. I said if you differentiate sine s with respect to s, you get cos x. If you differentiate cos x with respect to x, you get minus sine x. If you differentiate tan x, you get sec square x. If you differentiate cot x, you get minus cos x square x. If you differentiate cosec x, you get minus cot x cosec x. If you differentiate sec s, you get sec s tan x. If you differentiate log x, you get 1 over x. All of these are things I have introduced to you. So that means the only one I needed here was the differential of sine x. If I differentiate sine x with respect to x, I'll get cos x. So that the differential of, I'm differentiating u here with respect to m. If I differentiate sine x with respect to s, I said you get cos x. What if I differentiate sine m? I'll get cos n. The only thing that differs here is x and n. In that case, I was differentiating with respect to x. In this case, I'm differentiating with respect to m. You understand? So all that is required of you to do is to understand. Once you are done understanding, you don't have a problem. So by so doing this, the next thing to do is now obtain the product of your initial differential and the final differential. So that if I obtain these two here, by the time you obtain the two, what would you get? So my du dx, yes now, du dx, don't forget, my aim is to get du dx here. But if I can get du dx here, I need to go this way. Now that I've gotten du dx is a product of dm dx and du dm. So that one gives 2x times cos m. And that's 2x cos. Don't forget, my m is, go back here. Your m is what? S squared plus 1. Now I've gotten du dx. Don't forget, there are two things. Anytime you are differentiating using chain rule, the rule says if y is a function containing x, then the dy over dx is du dx times dy over du. And now I've gotten du dx. The next thing I needed to do is find dy du. So how do I go about getting dy du? Very simple. Come back to here, this place. Y is equal to E. Now, instead of writing this whole big grammar, I will come back. Don't forget, you have assumed the big grammar to be u. You have called everything here u. So that this particular thing here can take this particular dimension. Instead of writing the whole of this, I'll just replace with the dimension. Since I said u is this thing here. So that the dy over du, you are differentiating y with respect to u. And that one will give you exponent u. The differential of exponent x with respect to x is still exponent x. So as the differential of exponent u with respect to u will be what? Exponent u. Now that I've gotten the differential of y with respect to u, the next thing is to take the product of this answer and this answer. So that the dy over dx would be this particular one. Anyone can confess. This one, that's 2x cos x squared plus 1 times exponent u. And that's 2x cos x squared plus 1 times exponent. Don't forget, your u is what? Come back here. Your u is sine open bracket x squared plus 1. So instead of writing u, I will come back here and replace with this sine open bracket x squared plus 1. And that brings us to an end of this video. So all you just have to do is understand the principle, get the principle and work by the principle. By the time you get the principle, you understand the rules, work by the rules. And once you work by the rules, you don't have a problem.